This is a problem dealing with a three-way table, which is something you'll need in your stats project. So I'm going to read the problem. I'm going to read it up to here, and then we're going to deal with each of these questions on a separate page. So most patients who undergo surgery make routine recoveries and are discharged as planned. Others suffer excessive bleeding, infection, or other post-surgical complications and have their discharges from the hospital delayed. Suppose your city has a large hospital and a small hospital, each performing major and minor surgeries. You collect data to see how many surgical patients have their discharges delayed by post-surgical complications, and you find the results shown in the following table. Now, what's interesting about this table is that it has three pieces of variables, not just two. We're looking at discharge delayed for the large hospital for major surgery, and for the small hospital for major surgery, large hospital minor surgery, small hospital minor surgery. So there's a lot of different pieces of data here. So just for example, if I look at the large hospital and major surgery, I can see they had 800 patients, and 120 of those were delayed. A different example, same kind of thing. If I look at the small hospital, and I want to know about minor surgery, well, they had 250 patients, and 20 of them were delayed. So that's how you read a three-way table. So I made it a little bit bigger so we can do some calculations here for each question. So the first question asks, overall, for what percent of patients was discharge delayed? So the first thing I need to know is, well, what are the total number of patients? Because they're asking me about the total number of patients, not just large hospitals or small, or major surgery or minor surgery. So I can see there were 800 patients here, 50 here, 250 here, and 200 here. So 250 plus 50 is 300, plus 800 is 1100, plus 200. There were 1,300 total patients. And how many of them was discharge delayed? Well, 120 of them here, 10 of them here, 10 of them here, and 20 of them here. So that's 20, 30, 40, 160. 160 were delayed, and this is combining large hospital, small hospital, major surgery, minor surgery. 160 were delayed out of 1,300. Here's the calculator. 160 divided by 1300. Well, about 12.3% would be the answer here. 12.3% were delayed in their discharge. The next question is asking, were the percentages different for major and minor surgery? So they want us to now differentiate between major surgery and minor surgery. Well, for major surgery, I can see that I had 130 delays out of a total of 850 patients. So, as a percentage, that equals 130 divided by 850. That equals 15, let's call it 15.3%. So we'll call that 15.3%. What about minor surgeries? Well, I had 10 delays and 20 delays, so I had 30 total delays, and that was out of 200 plus 250. That was out of 450 surgeries. 30 divided by 450 equals, well, it looks like only 6.67% were delayed for minor surgeries. Now that makes sense, doesn't it? I mean, you would think a major surgery would be likely to have more complications than a minor surgery. So just intuitively, this is beginning to make sense, and I hope you see how I use the data in the table. Now it's asking me what were the discharge delay rates at each hospital. So instead of looking at the rows like we did with the surgeries, we're going to look at the columns. So in the large hospital, I had 120 plus 10, 130 delays, and there were 800 plus 200, there were 1,000 patients. So I can see that is a 13% delay rate at the large hospital. And at the small hospital, I had 10 and 20, so that's 30 delays out of 50 and 250 out of 300 patients. So at the small hospital, I only had a 10% delay rate. So pay attention to how we're using this data. I just want to point out one thing as an aside here. You don't really need to study this. It has a name, but you don't need to worry about it. You might think by looking at this, well, that at the large hospital, if I go to the large hospital, I'm going to be more likely to be delayed because it's 13% compared to 10%. But notice that the large hospital does a lot more major surgeries than minor surgeries, and the small hospital does a lot more minor surgeries than major surgeries. So the small hospital is doing more of the types of surgeries that are not likely to be delayed. That might be why they look better here. But again, mainly I want you to see how to use this table. Finally, they're asking us what were the delay rates at each hospital for each kind of surgery. So they want to know hospital and each kind of surgery. This one's pretty simple. So I'm going to do 120 divided by 800 for this box here. 120 divided by 800, and I get 15% for large hospital major surgeries. Oh, at the small hospital I have 10 divided by 50. Oh, so they have a 20% delay rate for major surgeries at the small hospital. That's interesting. Worse than the large hospital. For minor surgeries, 10 of 200, 10 divided by 200 is going to be 5%. So 5% on minor surgeries for the large hospital minor surgeries. And at the small hospital, 220 divided by 250, I have 8% on minor surgeries at the small hospital. So really, if you look at it types of surgery by types of surgery, the large hospital seems to be doing better, 15% compared to 20% and 5% compared to 8%. The reason the overall was different was because of that number right there for the small hospitals. So looking at this and then working on your project should help you understand how to do a three-way table.